So let's solve this particular question. The question is, what volume of oxygen would be required to burn completely 400 ml of acetylene? So you have got 400 ml of acetylene. Okay. Also calculate the volume of carbon dioxide formed. Okay. Fortunately, in this problem we have this balanced chemical reaction. We have this balanced chemical reaction. And what about these values? These values are what? Your stoichiometric coefficient. Okay, these values are what? These values are what? Stoichiometric coefficient. Stoichiometric stoichiometric coefficient. Okay, that is what is stoichiometric coefficient. Okay. Now, what information does this stoichiometric coefficient provide us? Okay, so basically this is what your 2 mole of C2H2, 2 mole of C2H2 reacts with 5 mole of oxygen and provide us what? 4 mole of CO2 and plus 2 mole of water. Okay, now here there is one assumption to solve this question, otherwise without that assumption we will not be able to solve this particular question. Okay, so what is that assumption? So your assumption is assumption. So what is that assumption? Okay, just look at this assumption. Throughout this particular reaction, your pressure and temperature is what? Constant. Pressure and temperature is what? Constant. Pressure and temperature is what? Constant. Okay, somehow. Okay, that is what? Constant. Okay, so this is our assumption, and if it is there, you know Avogadro's law. What is Avogadro's law? Avogadro's law tells us that Avogadro's law. Okay, Avogadro's law that tells us that at constant pressure and temperature, your volume is directly proportional to what? Number of moles. Okay, so now if your pressure and temperature is constant, you can use these stoichiometric coefficient like this also, that 2 liter of C2H2 instead of 2 mole, because these are what? Directly proportional. So instead of 2 mole you can use what? 2 liter of C2H2 reacts with what? 5 liter of oxygen gives you what? 4 liter of CO2 and plus 2 liter of what? Water. Okay, now this question is over conceptually. Okay, so you can see this is what you have. What? How much? 400 ml of acetylene. Okay, that means what? 400 ml means what? 400 upon 1000, that is equals to what? 0.4 liter. Okay, so you have what? 0.4 liter of acetylene. Okay, 0.4 liter of acetylene. So you can see from 2 liter of acetylene you are in need of what? For 2 liter of acetylene you are in need of what? 5 liter of oxygen. Okay, for the complete reaction. So just for 2 liter of C2H2, how much liter of oxygen is required? 5 liter of oxygen is required for complete reaction. So if you have 0.4 liter of what? 0.4 liter of acetylene. So for 0.4 liter of C2H2 we are in need of what? 5 into 0.4 upon 2. Okay, and that is equals to what? That is equals to what? This is equals to what? 1. Okay, so 1 liter of oxygen is required for complete reaction. Okay, so your first part is over. Answer is what? Your 1 liter. Okay, now again use this particular stoichiometric coefficient to solve the another part, that is what? Calculate the volume of carbon dioxide formed. Okay, so look at this. From 2 liter of C2H2, okay, make it black. Okay, 2 liter of C2H2, you form what? How many liters of carbon dioxide? 4 liter. Okay, so you can write it like this. From from 2 liter of C2H2, we form what, how many liters of carbon dioxide, how many liters, 4 liter of carbon dioxide. Okay, you can see, so it is what, 4 liter of carbon dioxide. So if it is there, this is the information we are getting from what, a stoichiometric coefficient. So from 0.4 liter of C2H2, how much liter of carbon dioxide will be formed in this particular reaction? So it will be what, 4 into 0.4 upon 2, and this will be equals to what, your 0.8 liter CO2 will be formed in that complete reaction will be formed. Okay, so I hope this particular point is clear.